Good afternoon, friends. Today we will see how the electricity is generated and how it is transmitted through the transmission line and how it is distributed through the system. Means from the power plant to house, how the power is transmitted and what are the stages. Today we will see overall picture of the power systems. This video gives a glimpse of the power systems, outline of the thing. So in power systems there are four stages are there basically. One is electricity generation. In this, power is generated through the different plants. There are different types of plants are there: thermal plant, hydel plant, nuclear plant, wind, solar. There are different types of plants are there. And second one is transmission system. Through this, the power is transmitted. And the third one is distribution system. Through this, power is transmitted to different areas. And the fourth one is the customer, means the end user. So this is the detailed picture of the power system. Here it is a power plant where the generator is the main thing. Here it is a step up transformer is there. After the generation, the voltage got increased more. Here 12 kV is the generator output voltage. Here it is step up to 120 kV, 400 kV. Now people are going for 700 kV also. So very high voltages are there. After this high voltages, the power is transmitted, and at the distribution side, this voltage got stepped down to very low value, 11 kV, 11 kV. After this step down, another pole mounted transformers are there everywhere. Because of this pole mounted transformers, you can step down the 11 kV to 400 volts. Because 400 volts is the line to line voltage, then the phase voltage is 230 volts. So house can access this 230 volts, right? We will go to the detailed things, how the generation takes place. So in generation of the electricity, there are different types of plants are there. One is thermal plant, and another one is hydel plant, nuclear plant, solar, wind, biogas, tidal energy, ocean geothermal. So these all plants generate the electricity. In thermal power plant, coal is the fuel. With this coal is the main fuel. With this coal, we feed it to the boiler, and boiler generate the steam. This steam will rotate the turbine, and turbine will rotate the generator. In hydel power plant, we create a difference of the height. Means there is water is stored at very high height, and the turbine is at very low height. When high height water falls from the reservoir to the turbine blades will rotate automatically because water hits the blades at a very fast pace. In the nuclear power plant, thermal power plant are the same, but here boiler is the main thing. Here nuclear reactor is the main thing. In solar and wind plant, solar is the very clear and clean energy. Means in solar, nothing, no pollution is there. In wind also, no pollution is there. Solar and wind are the pure energies. In biogas plants, whatever the waste that you are naturally producing, we use that waste, we produce the biogas. And tidal energy and ocean geothermal energy means it is related to the ocean. Because of the gravitational pull between the earth and moon, the tides are created in the ocean. So because of these tides, ebbing and flooding happens. Means the tide is moving forward and backward. We can harness the energy that ebbing and flooding energy means the, the tidal energy we can harness into electrical energy using proper water turbines. So in conventional form of electrical energy, conventional means thermal power plant, nuclear, this type of power plants, and hydel power plant. In conventional electricity, we have to rotate the shaft. Means rotating shaft is the main task here. To rotate the task, if you use the steam turbine or water turbine or any type of things to rotate the shaft, our main aim is to rotate the shaft. To rotate the shaft, we use different methods. So this shaft is connected to turbine. If it is a steam turbine, we have to produce the steam using boiler. If it is a water turbine, we have to use water turbine, because of the head difference, water will hit the turbine and turbine will rotate. So here boiler is the main thing. Here reservoir is the main thing. Here nuclear reactor is the main thing. Here here photovoltaic cell is the main thing, and here wind fans are the main thing, right? So this is the typical thermal power plant layout. In this thermal power plant, boiler is fitted with the coal. Boiler is fitted with the coal, and air intake is also there for the proper combustion. So fuel and air we will supply to the boiler. So here boiler also, two types of boilers are there in the system. The one is fire tube boiler and another one is water tube boiler. In fire tube boiler, flue gases are inside the tubes. Flue gases are inside the tubes. Flue gases are inside the tubes. Outside water is there. So this is called fire tube boiler. But in our system, it is a water tube boiler where water is inside the tubes and flue gases are outside the tube. Means flue gases are outside the tube, water is inside the tubes. Because of these flue gases are at very high temperature, very high temperature. Because of this too much high temperature, the water is converted into steam. This steam is diverted into turbine, and this turbine will rotate. Because of this rotation of the turbine, the electric generator also rotates. The shaft of the electric generator is rotated, then electricity is produced. Here it is a three phase, but people written as a plus and minus. It's wrong. It is a three phase. Three phase generation will takes place. After the turbine, the cooling process is there. Means after the steam got released, if its work got completed, and then the steam is converted into water again using the cooling towers, and this water is diverted into boiler by heating the water again. Means some heating is there. Here you have to heat the water up to some extent, and we will pump this water to the boiler again. Means we are using the water in a cycle. So the main disadvantage of thermal power plant is more fossil fuel emissions, because coal burning takes place, lot of emission of harmful gases like sulfur dioxide, carbon dioxide. It's not eco-friendly, but still people are going with the thermal power plants. And other one is hydel power plants. In hydel power plants, we have to create the head difference. Means water is stored at very high height and turbine is at very low height. If water if this gate is removed, the water is flowing through the penstock and hit the turbine. This turbine will definitely rotate. Here, steam turbine rotates very high speed, but this water turbine rotates very low speed only. But this speed is enough to create the electricity. And one thing you have to remember, in steam turbine, that is horizontally mounted generator. In this hydel power plant, it is vertically mounted generator. So here generator arrangement is vertically mounted. And here we use different type of water turbines, Pelton, Kaplan, Francis. Different type of water turbines are there based on the capacity we can use. And this is a nuclear power plant. So in thermal power plant, boiler is the main thing. In hydel power plant, reservoir is the main thing. In nuclear power plant, this reactor is the main thing. This is a reactor. With this reactor only we can control the chain reactions. Means here we use uranium as a fuel. Because of this uranium, if uranium is bombarded with the neutrons, then the reactions will take place. Means like the fission reactions will take place. For every fission, some heat is released. That heat is too much. Means within a less fusions only we can get more amount of heat, and this heat is diverted to the water, and water is converted into steam again, and then here steam turbine is there and the turbine will rotate. Here we have to control the fission process. To control the fission process we use control rods here. These control rods are there. These control rods will absorb the neutrons which are responsible for the chain reactions. If control rods are inserted completely into the reactor, then chain reaction stops. Means through these control rods only we can control the chain reactions. Unless until if you won't if you don't control the chain reactions, it will be very dangerous. Okay. Here also the recycle arrangement is there. Condenser, after condensing, water is reusing. This type of things are there. But you have to remember that in nuclear power plant, the reactor is the main thing, and because of the controlled reactions, the heat is generated through the nuclear fission process. This heat is diverted into the water, and water became the steam, and this steam is diverted into the steam turbine, and the turbine will rotate. Nuclear power plants are very less because of the safety issues. Very less number of nuclear power plants are there, and because so many incident happens, and some are very pathetic. And after the generation of the power there is a another stage is there, that is the transmission of the power. And in order to transmit the power we have to step up the voltage. Means the voltage is not enough. After the generation, the generator voltage is 11 kV, 10 kV, 12 kV. This type of voltage is there. With this voltage you are not going to transmit the power, you have to step up the voltage. So you may ask the question like, why we have to step up the voltage? What is the need of stepping up the voltage? So here I have taken example to clear the doubts. Suppose I have generated 1 megawatt. This is 1 megawatt. Okay, six zeros are there. It is like 10 lakh. 10 lakh watt I have generated. And the resistance of the power carrying conductors is 5 ohms. Means I have to transmit the power through the conductors only, right? So conductor has some resistance. 5 ohms is the resistance. So if my generator voltage is 10 kV, means 10,000 volts, the current flowing through the transmission conductor is what? Power by voltage. Here my power is 1 megawatt. My voltage is 10 kV. So 100 ampere current is flowing through the conductor. Because of 100 amperes, the power loss is there in the conductor because conductor has a resistance. Resistance will dissipate the power. This is the I square R power loss. So this is I square R. This is 50 kilowatt. 50 kilowatt we get. Out of 1 megawatt, 50 kilowatt is the transmission line. 50 kilowatt is the transmission line. Remember, if 10 kV is the voltage, 50 kilowatt is the transmission line. So, if we step up the voltage to 10 kV to 100 kV, the current flowing through the conductor is decreasing. 10 amperes only. Here, voltage got increased. If voltage is increased, current got decreased. And power loss is I square R. Here, it is 500 watts. Imagine how much amount of percentage power loss is reduced. Here it is 50 kilowatt. Here it is 500 watt. Nearly 100 times. 100 times reduced. Here it is 50 kilowatt. Here it is 500 watt. So because of this power loss only we will step up the voltage. If we step up the voltage to how much high, that much power loss will go down. So in order to reduce the power loss we will step up the voltage. After stepping up the voltage, power is transmitted through the conductors. These conductors are held by the towers. These towers are like the supporting structures. If you see, these are the towers. These are the towers. Here, these are the disc type insulators. Means so many discs are arranged in a series to withstand high voltage. With this insulator, we can hold the conductor here. These are the conductors. So this is the tower structure. These are the conductors. These are the conductors. And this is the substation where step up transformer is there. Some protective equipment is also there. If some fault happens, it will open, it will isolate the circuit. So this is a 220 kV substation. So after the transmission also has so many challenges, but I have just discussed as a one simple thing because I don't have much time. So after the transmission, distribution is there. In distribution side, some distribution transformer is there. This transformer and this transformer is different. This is a power transformer. This is a power transformer. Remember, this is a power transformer, and the rating of the power transformer is very high, and the transformer size is huge. This is a distribution transformer. With this distribution transformer, we are going to stepping down the voltage. Nearly, we are going to step down the voltage to 11 kV. We are in distribution side, we are going to step down the voltage in order to distribute the power to different areas. So see, there are four terminals are there: R, Y, B, neutral. Neutral is also there, but input side three are there. So in transmission side, only three conductors are there, but distribution side four conductors are there, because in distribution side you require neutral, because customer requires a neutral. So this is the typical layout of the 33 kV substation. In the substation, so much protective gear is there, like lightning arresters, surge arresters, so much of protective CTs, PTs for measurement, how much power is coming, how much power is going. This type of things are there. So this is 30 kV incoming line. After that, it got divided into two lines using buses. And after this 33 kV, there is another transformer is there, 11 33 by 11 kV, and this got after this 11 kV, it got converted into 400 volts, right? If 400 volts is the line to line voltage, 230 is the phase voltage we are getting at the houses. So this is after the distribution. Here this 11 kV to 400 volts transformers are there. These are the 11 kV to 400 volts transformer. So we are using only one phase, and in household application there are two wires are there, line and neutral. If you see this, you can understand. In household application, line and neutral are there. So only two wires will come out of the service mains, and these two wires will be connected to these two wires, line and neutral. Here maybe neutral is not visible here, only three lines is there, but neutral is there. I think here four lines are there. Okay, three lines. This is the fourth line. So we connect our service main to one line and one neutral. So this is the household arrangement. Here line and neutral is there. Here fuse is there. Here meter is there. And here MCB is there. Fuse is there. And here our loads are there. Here earth connection is there. Earth connection is very important to protect ourselves from the shocks. Right? So thank you. Thank you for listening me. Have a good day.